Alright, James, so I'm looking over this data that you sent me and something doesn't quite make sense. The only way to get an average attack-based score for electric shock this high is for a Pikachu to have been bred exclusively for homozygous recessive of the electric shock alleles. But this is often fatal for a Pikachu because the genotype is associated with hypertrophic cardiomyopathy. Oddly, the gene has a high variability, so you can still find other genotypes with very high ABS, but they'll also suffer from heart disease due to the stress caused by using the attacks. We classify these Pikachus on this end as being on the spectrum of being susceptible to cardiomyopathy disease.
Yeah, but that was a trick, wasn't it, for underground poke fighters? To breed for the recessive allele, even if it meant the Pikachu's fight would be its last. Because of genetic variability, some homozygous dominant and heterozygous genotypes could still have higher than average ABS, but that would also come with the risk of heart disease. At least with homozygous recessive, you'd be much more likely to have a higher ABS. But genetic testing is regulated these days. Even the underground groups can't do it. It's nearly impossible to breed exclusively for the recessive allele.
Unless you breed a large population, keep breeding the top 10% over and over again until you only have a population of Super Pikachus. To do this, you need to do the following. Assuming a broad sense of 0.85 and realized heritability of 0.67, the normal distribution of Pikachus look like this. If we breed for the top 10%, we can shift the initial population mean to the right of this graph. We calculate this by identifying the truncation point of the initial population or minimum base attack the parents must have to be bred. Our standardized selection point and standard deviation has been determined by Nintendo in the past. Using this number, we select our parents and bred them until we have at least 190 progeny. We can estimate the response to selection by defining the product of the selection intensity, realized heritability, and standard deviation. Both selection intensity and realized heritability have been determined by Nintendo through years of genetic testing. Realized heritability determines the proportion of phenotypic variance due to additive genetic effects, while broad sense indicates proportion of phenotypic variance due to some sort of genetic effect. This means that at 0.85, at least 85% of phenotypic variation is due to genetic effects. With a realized heritability of 0.67, this quantifies the extent to which a trait in a population can be pushed by a selection each generation. Response to selection estimates the difference between the mean of the parent's population and its offspring. With selection response calculated, we see that the new attack base mean of the X1 progeny is 118.24. This still doesn't fall entirely into the danger zone, but this data you uncovered shows population with an attack base much higher than the normal distribution chart of even the X1 progeny. To get these numbers, you'd have to repeat the process at least 5 times.
I know, but look at the address for the recent shipment of cages. You're not gonna believe this. Think about it. Who else has known every step that you've taken? Who was the only one who seemed to disappear when we all fought against Giovanni? Look, I know you haven't always trusted Team Rocket, but Jesse and I have been on this case since day one trying to figure out who's behind all these strange breeding practices. The evidence is clear.
Finn, look, if I have to see this for myself. This can't be it. If another generation of Pikachus are bred this irresponsibly, they'll mostly all die from heart failure. This can't continue.